Learning target 6.14, I can define chemical equilibrium using forward and reverse reactions. Chemical equilibrium is when the reactants are converted or turned into products, and products are converted to reactants at a constant rate. Okay, so where we have a forward reaction, we have a reverse reaction, and it's going at a constant rate. Okay, now the key, so sort of happening at the same time, right? Now the key is, however, that the concentrations, this means concentrations are not necessarily equal at equilibrium. Okay, so they don't have to be equal. The amount of reactants, you could have 4 moles on one side, and you could have 2 moles on the other side at equilibrium. This is okay. This is okay. All right. Another key point is that it does not stop. Right? It's not that the entire process has stopped and they're equal, right? It's that they continue to exchange, and in doing so, they are still exchanging at the same rate. Okay, so let me give you a visual example. So let's say you have two tubs, right? In one tub you have, let's see if I can find, you have a blue liquid. And take a note of the level of the liquid. Right. In the other tub you have a lot of yellow. Okay. So what we're going to do is we're going to pretend this is my reactants, this is my products, right? And we're going to pretend that we're going to have a reaction going. So reactants, I'm going to take this and I'm going to dump it in here. At the same time, I'm going to take the products and dump it back in there. Okay? This is a reversible reaction. Right? Your forward and reverse ones are going to occur. Now, they're going to occur at the same rate. So for every time I put like this much of product into the reactants, I'm going to put this much of the reactants into the products. Okay, so they're switching at a constant rate. Okay, now, what do you think is going to happen while the reaction is occurring? Well, you're actually going to see that's not as bad as I thought. Okay, so you're going to see them sort of changing colors, right? One's going to be a little more blue, one's going to be a little more yellow, but over time, you're going to get a nice, ugly green shade, right? And over time, no matter how many exchanges you make, it's going to remain at this level where you have less here and more here, okay? So note, the concentrations are not equal, that's okay. Not a problem, right? And note, it's not stopping, but your reactants are being converted into products, and your products are being converted into reactants at a constant rate, right? One block to one block. Okay? So this is at equilibrium. So let's go ahead and take a look at a possible question, or actually just a little quick check, an example question. Question is, true or false, equilibrium occurs when the number of products is equal to the number of reactants. Right, we just talked about this. The answer is false. Equilibrium does not have to be when the products are equal to reactants. The rate has to be equal. Not the amount. So think back, right? You have one that's this, and you have one that's this. They can be at equilibrium as long as they are both the same color. So even if you start out with a darker blue, at some point they're going to turn into this nice shade of blue. Okay. So false equilibrium occurs when the rate of the creation of products is equal to the rate of the creation of reactants. So go ahead and write that. Rate and rate.